All right, so we're going to move on to the word problem section in 3.1, and that involves solving exponential word problems. Now, typically, I would kind of explain where these equations come from, but out of the interest of time, there's just no time for me to derive these equations or formulas. So let me just kind of explain to you what these values are. How do you know specifically what formula to use, or how do you know when to use these equations? Well, first of all, it's going to say, car is increasing by 30% annually, right? The price or the value of a car is increasing by 30%, or the value of a house is increasing by 15% annually. So whenever they say there's an increase or decrease by a percentage, you know you're going to be using exponential growth. Or of course, if it's losing by percentage every year or monthly, right, you can use exponential decay. All right, so again, I would typically explain where these formulas come from or derive them with you in class, but there's just no time. So A is typically the initial amount, R is the rate as a decimal, T is in time, typically in years, but sometimes it could be months, and then Y is the total amount. Okay, so exponential growth and decay, if it says increasing by percentage or decreasing by percentage, you would use equation 1 or 2. Now, what about the compound interest formula? So this one right here, I just wrote y equals a times 1 plus r to the t, right? That looks almost identical to equation number 1. But actually, all I'm going to do right now is include this variable right here. N is the number of times compounded. And so what I'm going to do is I'm going to take my rate divided by n and also take my time and multiply by n. And there's your compound interest formula. Everything else means the same exact thing. A is the initial amount, R is the rate, n is the number of times compounded, and t, of course, is your time. Okay, so you use that when they say compounded annually, okay, annually or semi-annually. Right, or monthly, etc., etc. Okay, so you'll see that in the word problems themselves. All right, the last formula that you need to be familiar with is the continuous compound formula, and this formula really just comes from the definition of E. Again, I can show you where the formula comes from if we had more time, but distance learning just kind of cuts everything short, so we're just going to have to know how to use it. Okay, so this one, A is the total, okay, total amount. P is the initial amount. Right, R is your rate. Now notice I wrote two separate equations, right? K or P, okay, N or P, and Y or A. So both of these equations, they mean the same thing, okay? All right, so positive, right, you use positive R or negative R. If R is positive, R is less than 0, then you would use a positive rate for R or a negative rate for R, okay, depending on if it's growth or it's decay. And typically you would use this when it says the word continuous, okay, so there's no other easier way than to identify in the problem when it says continuous. Now also it's also used in bacteria word problems, population, okay, half-life, carbon dating, etc., etc. Okay, so those all typically model a continuous exponential situation. Okay, all right, so there's really only 3 formulas if you think about it, right? Growth, it uses positive R, decay uses negative R, and this compound interest formula right here, number 3, it comes from your exponential growth formula. All I inserted was an N, and for the continuous one, you use E.